Hi everyone. In the last video, we saw the background of Opamp. Today, before we getting into the designs of the Opamp, we must understand few basic laws how it works. Some people are already into this. They're already expertise in these laws. If some people do need some kind of a refresh of this laws, please go through this video. It will be helpful while designing the Opamp. The first law, it says that Ohm's law. This is the basic fundamental law in the physics. The second one is called the Kirchhoff voltage law. Third one is Kirchhoff's current law. The fourth one, what is needed for the op-amp design, is voltage divider law. The current divider rules. These are some of the 5 laws that we want to discuss today. To start with, actually, on the Ohm's law, let us understand for the people who are starting afresh. Think that there is a water hose or a water pipe, we call it as. And normally what happens actually is that the water flow in the water hose, or it's in the water pipe. If you try to press this water pipe, what will happen actually? It limits the flow of water here. Similarly, what you're trying to do, you're showing resistance by pressurizing this water hose, by pressing this water force, you're limiting the flow of the water. Think that this is a wire piece and the water can be thought of as a current. I can represent the current as I, and the resistance that you're trying to, that resistance you're showing by pressing this water hose, it can be presented as a kind of a resistor. This is a resistor part. There are various types of resistors. Let's not bother about. Let us understand the function of it. This resistor's job is basically like a gatekeeper. It tries to avoid or oppose the flow of the current. It tries to. Different resistance values opposes the current accordingly. So what we need to understand is that the resistance is basically mainly to oppose the flow of the current. Now, with this actually basic circuit, basic understanding, let us write one simple circuit. So what I do is that probably I just for the explanation purpose. Okay, so I'm going to write a resistor here. This is something. So this value will be feeding to another circuit, things like that. This is the voltage source. The circuit is connected back through the return path, and the current will have to flow like this all the way from here through the resistor and then back to this return path. This is resistors. This is the voltage source. And this is current I all over this circuit. I told you that there is an opposition to this current. So that means what happens while doing so, there is a voltage drop. I call this voltage drop as VR. Let us say that it's voltage drop, you can call it as V. Okay, so according to Ohm's law, what it says is that if we try to multiply this current by the amount of the resistance posed by this resistor component is equal to a voltage drop. Either you can apply to the whole circuit or you can apply to the individual component. So this is R1 and R2, and this is something called it as R. So let us say that this is, for example, if you think that the current through this particular portion is called as I small r, and the resistor is R, and the drop, I told you that whenever there is a flow of current through the resistance, there is a voltage drop. So the drop, you can mention it as VR. Okay. So what is now, according to the Ohm's law, what it should be? The voltage drop should be equal to the current multiplied by the resistance. What is the current? The current is, oops, this is current IR multiplied by the resistance R. This is called Ohm's law. Now let us go to the Kirchhoff voltage law. Normally, actually, in German, they call it as Kirchhoff, and in America, it's called Kirchhoff. What is Kirchhoff voltage law? Kirchhoff voltage law. Let us try to understand the Kirchhoff voltage law. Let me write a simple circuit again. Oops, so I'm sorry. Let us call this R1, R2, R2. So let me try to understand. This is the drop across R2. Can I call this as, let us say, VR2, whatever the voltage? Okay. So this is the current. Again, the Kirchhoff voltage law says that, I told you in the Ohm's law, according to the Ohm's law, what is the Ohm's law? The current which is going through the resistance, it creates voltage drop. The voltage drop is nothing but VR1 here, and the voltage drop across R2 is VR2. Okay. The Kirchhoff voltage law says is that the sum of the voltage drops in the series circuit. What is the sum of the voltage drop? This is VR1 plus VR2 plus so on and so forth if you have multiple. The sum of the voltage drops in the circuit is equal to sum of the voltage source. It is something like this. If you have if you think the voltage source as a overhead tank, which can have 10, which can provide the water for 10 buckets. So let us say up to 1, 2, up to 10. It can only provide up to 10. If you put 11th bucket, it cannot be able to provide 11th bucket, right? So it is a similar way the voltage source is a limited and finite source of the voltage. So the drop across here, which is always equal to the sum of the voltage sources here. What do you mean by that? This VR1 is the voltage drop across here, VR2 is the voltage drop across here. If you have the voltage drop across here, let us say VR3 again. So all these sum of these things should be equal to this voltage source. This cannot give infinite sources. Ultimately, it has to be balanced. That is called the Kirchhoff voltage law. Now let us understand the Kirchhoff current law. The Kirchhoff current law, I can call it as KCL. So think that there is a wires crossed like this through a junction. Okay, so the current is flowing like this. Can I call this as I1, I2, I3, I4? This particular Kirchhoff current law states that the sum of the currents which is flowing into the junction is equal to the sum of the currents which is flowing out of the junctions. What are the sum of the currents which is flowing into the junction? I1 and I2, which is going into the junction J. So I can call it as I1 plus I3, which is equal to sum of the current which is outgoing, sum of the currents which are leaving the junctions, basically. This is I2 and I4, which is leaving outside the junction. You can see here. So the Kirchhoff current law says that the sum of the current which are inflowing into the junction or entering into the junction, which is equal to the sum of the currents which is going out of the junction. It's very simple. I1 plus I3 is equal to I2 plus I4. It's as simple as that. Now let's move on to the other one, the fourth one, what is called as the voltage divider rule. What is this voltage divider rule? So you would have studied actually in transistor cases and all, if you want to bias the transistor, or if you want to take some uh, lesser voltage, uh, if you want to tailor cut the voltage, let us say that you have a 5-volt battery. Think that, okay? You're connecting this battery to a LED. This LED requires, let us say that you have, okay, this LED requires only, what do you call that? 2 volts. You don't require 5 volts. What do? You're trying to take the divider and you try to give the voltage which is required only for this particular LED. Okay, so you want to divide the voltage based on the ratio of the resistors. So that voltage ratio, maybe let us say 1:2 ratio. That means 1:2 or half, so that means you're 1:2 in the sense it's like maybe this is 1 and this could be like, so let's go to the fourth one, voltage divider rule. What do you mean by voltage divider rule? So you will take the voltage. You don't want the complete 10 volts. Let us say that you have around 20-volt battery. Okay, but you don't want to consume this 20-volt battery. You just require a 5-volt or 10-volt. What you do is that you take the ratio of this one. So maybe here it is like the voltage drop of um, so it's one fourth or one half of it. Let us say you want some circuit to be run at 10 volt, one half of the voltage, one half of the voltage you take. So 10 volt and 10 volt. This is where you're dropping the voltage. So based on the ratios of this network like this, and this is the voltage which is 10 volts. Now you can use it for many applications here for 10 volt applications. So this is how we are going to down the voltage level to the required level based on the resistor selections. How do we arrive at all these things? How do we find out the voltage divider? The formula for the voltage divider, it's very simple. Let us write a very simple diagram here. This is resistor. Can I call R1? Can I call R2? What I want is that this is the voltage where I want it. The same thing, I can write it in a different way altogether just to make you understand. This is what resistor R is concerned, R1. This is the point A. This is the point B. Okay. This is the point A. After that, this resistor is there. It is called R2. Then it is going to the return path. Now, what do you want? What is the voltage across this is? This is where I'm interested in. Let us say I call it as V out. So V out, that is at this point, junction point, and this is B is a return path, right? So I call this as V out. Okay, this is V out. This is where I'm interested in. So based on the ratios, I'm dividing this particular voltage, the overall voltage, to a desired voltage level by choosing the right resistor. Okay, this is the same diagram. I have just written it like this. Now let us try to use first one, Ohm's law. What is the drop across this one? This is series circuit. So V is equal to IR applies, right? So you should always think that one. Second one, you should apply KVL. That is called as a Kirchhoff voltage law or Kirchhoff voltage law. So the current through this one, I call this as I. Okay. V is equal to IR is the first one we saw that. Next voltage is equal to IR1, I into R1 plus the IR2. What does it say? The voltage across this resistors, I call this a VR1, and this is nothing but equal to VR2 or V out. This is nothing but equal to VR1 plus VR2, or this is also called it as V out. This is nothing but your KVL. Okay, now let's just derive it. This is pretty simple now. So V is equal to, you can take this I. I'm interested in this particular portion of the circuitry. I call it as IR2. I will take it. So if I take this common, it is R1 divided by R2 plus 1. Now, what is IR2? The current through this resistor is nothing but IR2 is what? IR2 is nothing but, you can see here, VR2. Or it is called V out. Either this or this one. Fine. So now V is equal to, can I call this as V out into is R1 by R2 plus 1. You can solve this one. V is equal to V out is equal to, it is R1 plus R2 divided by R2. Now, just solve for the V out. V out is equal to V into R2. Bring this R2 here, divided by, it is R1 plus R2. You got it now? This is nothing but your actually the V out. This is V out is equal to V into, it is R2 divided by R1 plus R2. This is voltage divider rule. Let's do one thing. To understand logically, I'll write a very simple circuit. This is the circuit we saw here. The same circuit, I'm writing it down. You have 20 rupees with you. You want to spend. Resistance R1 is nothing but your voltage drop. So your money drops here. Let us say, I don't know what's the money drop, but it drops around 1/4 of money drop here. If it's 1/4 of money drops, it cannot go much beyond that. The total amount of rupee, 1/4 means it has to drop around 3/4 of money drop here. They're asking, what is this? This is where I'm dividing the voltage. What is the V out, right? What is the value at this juncture? I know only 1/4 of it and 3/4 of it. Don't jump immediately. Let us understand this is R1, this is R2. Okay. 1/4 means consider any value, random value, let us say 10 ohms. 1/4. If it wants to become 3/4, it becomes 30 ohms. Correct? Okay. So 1/4 of it. So 1/4 is 10 ohms, 3/4 is 30 ohms. Now, let us apply this formula. What is V here? 20 rupees. 20 into, what is R2? This is R2. 30 divided by 30 plus 10 according to this formula. 20 into 30 divided by 40. 2s are 2 15s are. So you got V out is equal to 15 rupees. So can we just apply here? 1/4 of 20 rupees is what? 5 rupees. 3/4 of 20 rupees is what? 15 rupees. Very simple. This is what you get it from this formula. Now you understand what is a voltage divider formula. It is pretty simple. It is, you can just say that wherever you want to take the voltage output, this is the voltage, this is the area where you're trying to divide the line of voltage. So this is the voltage with respect to the ground. If you take V out, is this portion is coming from the main voltage, that is V. This is the main voltage V. And here the with respect to a portion of this main voltage is dropping here. The portion of the main voltage dropping is based on the ratio of the resistors that we use it. So just see it once again in the YouTube. You can rewind and you can watch it once again to better understand the voltage divider. It's a pretty simple rule. Now let's move on to the last one, that is called as the voltage. I'm sorry, current divider rule. Current divider rule. Here, let us understand the current divider rule. What is the current divider rule? Let us say this is a current source. This is R1 and this is R2. So earlier, actually, you saw a series circuit like this, right? So the series circuit like this, the current will be same here. You will not have a different current. In the case of series circuit and parallel circuit, in parallel circuit, current differs. Similarly, it happens here. If this is the current which starts from this sourcing point I, because these are parallel circuits, the current divides I1, I2. And the current flows through this R1, current flows through this R2. Now, what is the current divider rule? Current divider rule is something like this. This is where I want to find out the voltage. I mean, this is the voltage where it drop across R2. Now, let us understand. This is the, let us apply the first one. We should not use too much of intelligence. It's very simple. Apply KCL rule. What is KCL? You must understand KCL is nothing but, already I told, the incoming to the junction. Incoming current to the junction is equal to the sum of the outgoing currents. The sum of the incoming incoming currents entering into the junction is equal to the sum of the outgoing current. What is the incoming current? I, which is equal to what are the outgoing currents? It is I1 plus I2. Simple. Just apply the process. KCL. What is voltage across this? So can I call this as the voltage across this is VR1, correct? So the VR1 or the voltage drop, let's understand the voltage drop. Let us say voltage drop is nothing but equal to this one, IR1. The current is I1 into R1. The same voltage drop also appears here, which is also equal to I2 R2. The same voltage. For example, if the voltage drops here across this line point and this line point, I call this as line point and A and B. If you put a multimeter, the current can take a different, quantity based on the resistors here. What is current? The current is opposed by what? Resistor. If the more resistor, more current opposes. If less resistor, less current opposes. If both are equal, the equal current flows through it. Now, at this point junction, A and B, if you measure it, the drop across this I1 and R1 is, let us say, V. Now, based on this resistor, again, the current and the resistor voltage drop should be same, but the current will differ because based on the resistor. Just for a kind of an example, if you take R1 is equal to R2, the current flow will be equal. Simple. Okay. Now, let us understand. We can derive the formula over here. So what is I2? I1 is equal to, you take this one, I2 into R2 divided by R1. Okay. Now, so this I1, you got this value. Can we apply the same thing, I1 into this I1? Yes. It's I2 into R2 divided by R1 plus I2. You got the common factors here. I2 into, it is R2 divided by R1 plus 1. I is equal to, it is R1 plus R2. Solve this problem. It is R1. What we want to find? We actually want to find, in this current divider rule, what is the current which is going in this particular path? The current which is going in this particular path is I2. You have here I2. So I2 is equal to, it is I into R1 divided by R1 plus R2. The similar way we deducted this. I2 once again, I into R1 divided by, it is R1 plus R2. Just memorize this. This is nothing but your current divider rule. So these are some of the fundamental laws that we wanted to discuss today. Thanks for watching this video, and we'll meet you in the next video with additional information on the Opamp. Thank you so much.